first part is called rectification. What does it mean to rectify something?
Change it into something else, like to make
To
sure.
correct something,
Redirect it.
What do you say?
to like correct something?
Yeah, okay, to make something right, okay? We're gonna rectify, okay? Like, if I got a bad grade on the test because the instructor, marked it wrong on accident, I'm gonna look for rectification, okay? So, in this instance, the negative voltage, they're bad. Okay, so we need to make them right. So what do? The machine flips all the negative and makes them positive. Okay, so if you notice, this is a rectified wave. Is there a negative? No, they're all positive. Okay, so if there's one category to work with, the machine can work faster, right? Yeah, it's just like that example that I gave you guys of those, of the M&Ms. If you have 100 or like 2 colors of M&Ms and you have to separate them, how long are they gonna take? It's gonna take you a while, right? But if you have one color, you can just put them aside, right? Because they're all the same. Okay, so that's what rectification does. Okay? Now smoothing or enveloping. Places a smooth line around the bumps and evens it out. Okay, so each of these peaks has its own information, right? It's its own wave. Okay, so it would have to process each of those waves information. Okay, but what it does, instead of having, 3 waves to identify, it turns it into one. And this is another one, this is another one, this is another one, this is another one. Okay, so the machine is making it easier for those sound waves to be interpreted, okay? By switching all the negatives to positive and then putting all of the waves into their own categories, okay? Smoothing and rectification, okay? So the smoothing happens by evening out the lumps, and rectification happens by turning the negative amplification into positive. Okay, and those two together make it easier for the machine to process that information. Because the faster the machine processes the information, the more accurate our images are. Okay, so this doesn't make our images better or clear, it just makes it more efficient. Okay, if it's able to process more information faster, then the efficiency of the machine is better, which means that everything happens faster and we don't have to worry about having to make so many adjustments, okay? So demodulation is a 2-part process. What's the first part? Rectification, which means what? Changes the negative to positive, and then what's the second part? Smoothing, which does what? It puts all of those waves together in their own little subcategories too, right? So what does that sound like?
Logarithm?
Yeah, okay, so that sounds like compensation, right? Like log compensation or dynamic range. Okay, so it's kind of the same thing. Okay, so it's putting them into subcategories to make it easier for the machine to process.
Would this be, anything to do with like the eye touch on the new machine? How like you press the button and it's
No,
just,
no.
No, there's
No.
is there a button for? No, right?
No, this already comes preset in the machine. The iTouch is, I think, yeah, that's spatial compound.
Oh, okay. You haven't touched that information yet, huh?
No, yeah, we will do. And then reject. Okay, so reject allows the sonographer to control whether a low-level gray echo scale information will appear on the image. Okay, so here we have the bladder. Should the bladder look anechoic?
No.
Yes. Okay, if there's echoes, especially in the inferior portion of the bladder, it may be misidentified as sludge. And what does sludge tell us?
Hardening
Well, there's classifications, but what is this a result of? in most cases?
Misdiagnosis.
Huh?
A misdiagnosis.
Sludge can indicate a UTI.
Mm.
Okay? If there's an infection in the bladder, we will see sludge. Okay? But is it really sludge there?
Mm.
No. Okay? This is artifact, and the way that we get rid of this artifact is with reject. Okay, so reject gets rid of the low intensity echoes. Okay, so we want some of the low intensity echoes, right?
Yes,
Like when?
like when you're.
Like early stages of the disease. Mm. It's like early stages of the disease. I don't know.
That's not easy. Allison? No? Okay, so what's the difference between a cyst and an abscess? Okay, so the cyst is fluid filled, and the abscess is also fluid filled, what is it?
With pus.
But it's complex, right? Okay, so we would want those low level echoes so that way we could accurately define an abscess, right? Okay, but if we know that it's a simple cyst, we would increase the reject to get rid of those echoes. Again, so for Doppler, okay, so when we do vascular mixture, it's gonna pick up the low velocity blood flow. We have to decrease our reject to let those echoes in. Okay, that's gonna help out with identifying blood flow.
So how would you fix it on a machine?
There's a knob or a button that says reject.
Is this like what you were telling me about the gallbladder? You know how
Yes.
it's like, okay,
Mhm.
so that's what I would have.
Increase.
Increased it? Okay.
Increase the reject.
Okay.
Yeah. So, rejection affects all low level signals on the image. Okay, so for me, I picture reject as a bouncer. Okay, so there's a guy standing at the door making sure that everybody is 21 and over, right? Okay, so the reject is a bouncer. Okay, so the reject tells the echoes, what's your voltage? No, sorry, too low, we don't want you.
Mm.
You're good, come on in. We're gonna use you for our image. Okay, so we could increase and decrease the reject. Okay, so we could tell the reject, you know what? I want it to be a cougar party, only 40 and above.
Yeah.
Okay, or we could lower the reject and say it's all ages and everybody gets it. Okay, so that's exactly what reject does. Okay, it tells which echoes can be used for the image and which ones can't be used for the image.
Mm.
Okay, so again, this is very situational. When do we want a low reject? Yes, when you're trying to differentiate a cyst or an abscess, or when we're doing vascular ultrasound, okay? Because we need to pick up that low velocity blood flow. Okay, and when do we want a high reject?
When you're trying to get rid of like artifacts.
When you're trying to get rid of artifact, exactly, okay? So when you're trying to make a cyst look anechoic, when it's just a simple cyst, or the bladder look anechoic when there's no sludge, right? Does everybody understand the concept of reject? Okay, now we have. Yeah, we didn't have to do this tomorrow. Okay, so tomorrow we'll pick up on dynamic frequency tuning. Is there any questions today?
No.
Thanks,